We are doing L'Hôpital's Rule Part 2, where we do some test type and exam type questions. So, just to recap from the first part, video 1, L'Hôpital's Rule, there are 7 different forms of L'Hôpital's Rule, or we call them the indeterminate forms. So, 7 different indeterminate forms. So students often get this wrong. They only know these two quite well, infinity over infinity and 0 over 0, but they're not aware of the other 5 forms, which are 0 times infinity, infinity minus infinity. Now remember, for these two forms, we will change to a fraction so that we can do L'Hôpital's rule. For 0 times infinity, just recall, a times b as a fraction is a divided by 1 over b. And if we have infinity minus infinity, if we get that into indeterminate form, we will find the LCD. From there on, do L'Hôpital's. Then, very important, these 3 indeterminate forms with exponents 1 to infinity, infinity to the 0, or 0 to the 0. So what will we always do in those ones? We will ln both sides and then use our ln laws. But more on that while we are doing the test questions. So let's just see. We did our theory. Now we're going to do some examples. So let's do number 1. Use L'Hôpital rule to find the following limits. If they do not tell you to do L'Hôpital's, let's check why it is. Since if x approaches 0 for arc sine x, we will get 0. Just to recap, here is our arc sine graph. Remember, your arc sine graph, your domain is between -1 and 1. Your codomain between negative pi over 2 and pi over 2. Hence, as x approaches 0, my graph will approach 0, and the bottom will approach 0, and hence I have my indeterminate form. What will I do? I will do the derivative of my numerator. So students still get that wrong sometimes. So by now you know that you really have to study your derivatives hard. The derivative of arc sine is 1 over square root 1 minus x squared. The derivative of x is 1. Remember what I said students get wrong. Often they forget to simplify before they attempt the limit again. So I simplify, and as x approaches 0, my answer is 1. So that is quite a simple one. The next thing, so let's see why it is an indeterminate form. Remember, cosec is 1 over sine. I still see that some second years get that wrong. Remember, cosec 1 over sine. Now, as x approaches 0, 1 over x will approach infinity. Let's just recap. So, as my denominator is getting smaller and smaller, my fraction will get bigger. So, the same situation here. As x is approaching 0, sine 0 is 0. 1 over the denominator approaching 0, infinity. What do I see? I get here, very, very important, I get my indeterminate form. What should I do? Now let's recap. We said if we have infinity minus infinity, we will get an LCD. So what is our LCD here? It's x sine x, so you times the first fraction by sine, the second fraction by x. Now, what do we see? if I substitute 0, get 0 minus 0, bottom I get 0. What must you realize now? That you again get L'Hôpital's, and hence you will do the L'Hôpital's rule again. We will derive the numerator, which is cos x minus 1. We will derive the denominator, which is the product rule. So I get sin x plus x cos x. Remember what I said, a common mistake students make, they will derive the whole fraction using the quotient rule. No, what does L'Hôpital's rule say? We derive top and we derive bottom. I derive cos negative sin x. Derivative of 1, 0. Derivative of sine, cos, and then I will use my product rule here again. Now, what is very important here? What do I see? I will get at the top as x approaches 0, for the sine graph is 0. Just remember what I've stressed in the first video. It's very important to know your sine graph, your cos graph, and your tan graph very well for limits. So as x approaches 0, sine will approach 0. As x approaches 0 for my cos graph, so similarly you have to know your cos graph quite well. Remember that's pi over 2, 3 pi over 2. As x approaches 0, your cos graph will approach 1. What do we get here? Cos will approach 1, but sine 0. So, what's your final answer? 0. My next problem, I need to do the limit as x approaches 0 from the right of x to the power of x squared. So let's see what is my indeterminate form. X will approach 0. X squared will approach 0. Hence my 0 to the power of 0, which is an indeterminate form. What did I say? That whenever you get the exponential indeterminate forms, you will say y equals to your function, but you will ln both sides. What did I do here? First I said y is equal to my functions. Next I ln both sides. What did I do? Ln of a limit, limit of ln. So I can bring that in. Now, very important, what do I see here? I am going to use my ln laws. By now we have done a lot of ln laws. We have applied it often. You always take the exponent to the front. Hence this method, when we have the exponential forms. What did I do? I took my x squared to the front. Now, what did I say in the previous video? Because x squared is approaching 0, ln x as x is approaching 0 from the right is negative infinity. Let's just recap that. There is my ln graph that will continue indefinitely, and here towards negative infinity. So as x is approaching 0 from the right, my ln graph will approach negative infinity. Therefore, I have my indeterminate form, 0 times negative infinity. So to recap, when I get 0 times negative infinity, which is an indeterminate form, I must always go back to a fraction so that I can use the L'Hôpital's rule. So what did I do here? I always keep the more complicated function in the numerator. The x squared will go to the denominator, hence 1 over x squared. What do I see here? As x is approaching 0 from the right for ln x is negative infinity. 1 over x squared, remember my denominator getting smaller and smaller, so my fraction getting bigger. And what do I see? Negative infinity over infinity, indeterminate form. So I derive again my derivative of ln x, 1 over x. My derivative of 1 over x squared is negative 2 over x cubed. Now, before you carry on, remember I said a common mistake students make, they leave it like that and then check the limit, which can be complicated. Remember in maths, we never use a fraction or leave a fraction inside a fraction. What did I do? I tip and times here. And remember to take this ln y down with all your steps, otherwise you're going to make a mistake. So when I simplify this, remember I can take the constant outside. X cubed divided by x is x squared. But as x approaches 0 from the positive side, x squared is 0. Hence, ln y is 0, but I need to get y by itself. Remember back to the form where you're going to take away ln, so you get e to the 0, and my answer is 1. My last question, exam type question that I'm going to attempt here is this one. So let's see why the indeterminate form. 1 stays 1, 3 over x as x approaches infinity. Now, recall what I've said a couple of times now. If you have a constant over x, your denominator getting bigger, so your fraction is approaching 0. Very important. And then also, what do you see here? Also the same situation. My fraction is going to approach 0 also. But my x is approaching infinity. So I am left with, what am I left with? 1, this fraction approaching 0, the next fraction approaching 0, x approaching infinity. I'm left with 1 to the power infinity, which you know by now is one of your 7 indeterminate forms, and we're gonna use the Hôpital's rule. But since, let's go back, since it is one of our very important exponential indeterminate forms, 1 to the power of infinity, we will do the following. We will let our problem be y. Remember I said that's the first step in the exponential indeterminate forms. The next step, you will ln both sides. Now, a common mistake students make, they forget to bring this ln y down all the time. Now, because I've learned, I can use my very important ln law. If you have to the power of x, that x will move to the front, hence my x there. Then remember what we've seen by now, a times b, you want to change it into a fraction. Your more complicated function will be at the top. X will move to the denominator, 1 over x. So that step extremely important. Now what we're going to do, a common mistake students make, they forget that the derivative of ln fx is f prime x over fx. What did I do? So the derivative of 3 over x, negative 3 over x squared, the derivative of 5 over x squared, negative 10 over x cubed, that was my derivative, over fx, which is just my brackets. Hence my brackets at the bottom. Then my derivative of 1 over x, negative 1 over x squared. Another mistake, common mistake from students. Remember what I said earlier, you first simplify this. We never work with a fraction inside a fraction and then divide by a fraction. What will we do? We will first get the LCD there, which is x cubed. If I times by x cubed, I get negative 3x minus 10. So that is my numerator simplified. My denominator there simplified. Also an LCD. So that is my denominator simplified. But I'm dividing by negative 1 over x squared. So I will tip and times. Remember, for you who are not familiar with the term top, tip and times, you will go, if you have to do 2 divided by a over b, 2 over 1 times b over a. So you tip the bottom fraction and you times it. So now what do we have here? What I did there, I have my fraction times negative x squared over 1, but again tip and times. When I divide by a fraction, I tip it, so the denominator becomes the numerator becomes the denominator. Now I'm just going to cancel. So if I cancel, I have negative x left. And there I have minus 3x minus 10 over x squared plus 3x plus 5 left. All these steps I'm not explaining in detail. As you can see, the fractions are basically from grade 8 and 9. Students should not be struggling with that. Now we're going to do the limit to infinity. Now remember what I said earlier, common mistake. Students forget to take the ln y down. Do not forget that. Now also a common mistake from students. Since it's limit to infinity, they forget that they must take out the factor with the highest exponent. So I'm taking out x here, so I get negative x squared. But I can also take out the negative, so I have a plus. But if I take out x from 3x, I just get 3. If I take out x from 10, I get 10 over x. Remember, taking out means dividing. At the bottom, I'm taking out the x with the highest power. I'm taking out x squared. So I will be left with this fraction. Now, what I've mentioned earlier, this will approach 0, 0, 0. These will cancel, and I'm left with 3 over 1, which is 3. We need to get y by itself. Y is e to the 3. Bringing this ln y down, important, that way I will not forget that I have to solve y. Just to recap, because I made my problem that I have to evaluate my limit equal to why. So those were a couple of exam type Hôpital rules questions. What you need to understand, Hôpital is extremely important for the next part, which is the convergence or divergence of series. And we're actually going to use Hôpital's rule quite often, hence the two videos on Hôpital's rule. So make sure you watch the video part 1 and 2 on Hôpital's rule before you attempt our next series, which will be the videos on the convergence and divergence of series.